Okay, so here's a little bit of practice here. So you're going to use those rules, 1 through 5, determine how many significant figures each number has. Generally, what I do is I put a check over the ones that are significant and an X over the ones that aren't. So take a moment, pause this tape, then unpause it and see your answers. Okay, so for number 6, beginning zeros, not significant. So that one only has 3. This one, middle zero, it is significant, 5. Another example of a middle zero. Remember, I'm not even worried about decimal point until I look at placement. Okay, ending zeros can or cannot be significant. If there's a decimal point, they are. There is not, so this guy just has 2. Beginning zeros, not significant. The 3 and the 4 are. The middle zero is. The 4 is. An ending zero, is there a decimal point in the problem? Yes. So it is significant. And the last one is an ending zero, no decimal point, not significant. Okay. Determining the number of significant figures and rounding. So most of the time what we're going to be doing is actually taking our answer to the problem and then rounding it. So let's see how we do here. We're rounding all of these to 3 significant figures. So what you want to do is start from the left, count 1, 2, 3 significant figures, and then that's where I'm going to end it. I look to the next digit to tell me whether I'm going to round it up or keep it the same. Right? We never round down. It's either keep it the same or round it up. Since 7 is 5 or greater, it's the same rounding rules that you've always used. The answer to this is 315 meters. If you think you got it, pause it right here, do these next 2, and then check yourself. If not, keep on with the recording, and I'll go through them. So the next one, 1, 2, 3. 2. 2 says I'm going to keep it the same. So do you think I should do 879? That's 3 significant figures. But does 8,792 really round to 879? That doesn't make any sense. 8,790. See how I added that 0 down there? Did I add any significant figures? Well, no, because that 0 is there without a decimal point. So, yep, this number still has just 3 significant figures. And the final one, remember these beginning zeros are not significant, but doesn't mean we can get rid of them. 3, 2, 8. The 8 is going to be rounded up. So 0.000329 kilograms. And then finally is our calculations with significant figures. And this is really, this rule and that last rule is really putting it all together here. What we're going to do sometimes is we're going to be adding and subtracting or multiplying and dividing numbers, and we need to know how to keep track of how many significant figures there are. When we're adding, here is the rule. I want to pause and write this down. You round your answer to the number of decimal places. And the operative word here is decimal places. Look at this rule. There's not even a mention of significant figures. Round your answer to the number of decimal places as the number with the least number of decimal places. So when I go and I actually do this calculation, so in my calculator, I'm plugging in 12.4 plus 5.003. The answer my calculator gives me is 17.403. And now I look at number of digits past the decimal point. Significant, zeros, it doesn't matter. They all count. So this guy has 1 digit past the decimal point. This guy has 3 digits past the decimal point. So my answer should just have 1 digit past the decimal point. I look and see, do I round up or stay the same? I stay the same, 17.4. And remember, a meter plus a meter is just a meter. You're just adding length there. Take a second and pause, try number 16, and then unpause and see how you did. So in your calculator, when you put 9.5 seconds minus 5.39 seconds, your calculator will give you 4.11 seconds. And then you look 1 decimal place, 2 decimal places. So my answer should just have 1 decimal place. So 4.1 seconds should be my answer there. More often than adding and subtracting, you're going to be multiplying and dividing in chemistry. So this is the rule that you're probably going to use most often. So be sure to write this rule down. In multiplication and division, you round your answer to the same number of significant figures as the number with the least number of significant figures. That's why those 5 rules at the beginning of trying to figure out how many significant figures a number has is really important. So I take 3.55 times 6.7. I look at it and I found out what my answer is in the calculator. The calculator tells me it's 23.785, and of course a meter times a meter would mean a meter squared. And now I go back and I look at how many significant figures. So that number, 3.55, has 3. 6.7 has 2, which means I must round my answer to only 2 significant figures. That's why we practice that rounding. The 7 tells me to round up, so my answer is 24 square meters. And finally, 100.3 meters divided by 3.5 seconds, so this would be like a speed here. My calculator gives me 28.6571429. It just keeps on going. Now look at my significant figures. 100.3 has 4. Those zeros are significant because they're in the middle. 3.5 has 2, so my answer should round just to 2. So that is going to be 29. And when I have a meter divided by a second, my answer is simply the unit of meters per second.